Welcome to my channel. In this session, we will discuss the concepts of ratio proportional variation. First part, we'll discuss concept of ratios in this session. In the next session, we will discuss proportion and variation. Ratio is a relation. It's a relation in which one quantity is expressed in terms of another quantity. Suppose if let's say there are two quantities A and B, we write it as A is to B. That means we are expressing A in terms of B. We can also express this as A by B. Suppose if I have 8 is to 2, or this can be written as 4 is to 1. We are trying to say the first term is 4 times of the second one. We are expressing first term in terms of the second term. So the ratio of two quantities A and B is expressed as A is to B. This can also be expressed as A by B as we discussed. Right. Here in this ratio, the first term is called antecedent, second term is called consequent. The first term A is called antecedent, second term B is called consequent. Let's take an example. If there are 30 boys and 20 girls in a class, we can say that the ratio of boys and girls is 30 is to 20. 30 is to 20, when you simplify, you will get 3 is to 2 or 3 by 2. So please remember, when we say that in a class the boys and girls are in the ratio 3 is to 2, we should not consider them only to be 3 and 2. There may be 3 boys and 2 girls. Maybe like this question, there may be 30 boys and 20 girls. There may be 15 boys and 10 girls. When I try to simplify, again I'll get 5 3s, 5 2s. So basically, whenever we say the ratio of two items is 3 is to 2, the first one is a multiple of 3, let us say 3 into k. Second one is multiple of 2. This k is a common multiple both cases. So when you find the ratio, this k gets cancelled. Here, this 10 gets cancelled and we are getting 3 is to 2. Here 15 and 10 means 5 is getting cancelled and we are getting 3 is to 2. So what we should keep it in mind in ratios is, whenever you are given a ratio as 3 is to 2, don't assume them to be only 3 and 2. It should be a multiple of 3, 3 into something. Second one should be a multiple of 2. Next. A ratio is an abstract quantity. It doesn't carry any units. Say for example, if I ask you to find the ratio of 3 kilometers to 450 meters in its simplest form, first of all, to compare two items, they should be expressed in the same quantity, same units. So 3 kilometers means we can write it as 1 kilometer is 1000 meters, We can write it as 3000 meters. This is 450 meters. When you simplify, we can say 15 3s, 15 20s. We can say 20 is to 3. 20 is to 3, that's it. It will not be 20 is to 3 meters or anything. Ratio will not carry any units. Right? So that is important. Next one. There are a few terms that we should be familiar with in ratios. The first one is duplicate ratio. Duplicate ratio is nothing but square. A square is to B square is the duplicate ratio of A is to B. 2 is to 3. What is its duplicate ratio? Means 2 square is to 3 square. Similarly, triplicate ratio means cube. A cube is to B cube is the triplicate ratio of A is to B. 2 is to 3. What is the triplicate ratio? 2 cube is to 3 cube. And subduplicate means it is square root. Square root of A is to square root of B is a subduplicate ratio of 2 is to 3. For example, for 2 is to 3, what is the subduplicate ratio? Root 2 is to root 3. And subtriplicate means it's the cubed root. 2 is to 3 ratio will be cubed root of 2 is to cubed root of 3. Right? And one more term is compound ratio. What is a compound ratio? Compound ratio of two ratios is product of antecedents is to product of consequents. Say if two ratios are A is to B and C is to D, the antecedents means the first terms A into C is to B into D. For example, compound ratio of 2 is to 3 and 4 is to 5 is 2 4s 8, 3 5s 15, 8 is to 15. Right? Then the ratio A is to B is called a ratio of greater inequality if A is greater than B, and the ratio A is to B is called a ratio of lesser inequality if A is less than B. And there are two important observations on this. First one is, in a ratio A is to B, if A is greater than B, that is, if it is a ratio of greater inequality, A plus X is to B plus X is less than A is to B when x is positive. Let me give an example. In a ratio 3:2, where 3 is greater than 2, 3 plus x is to 2 plus x. You can take any number. Let's say we take 1. 3 plus 1 is to 2 plus 1. This value is going to be less than 3:2. Let's check. 3 plus 1 is 4. 2 plus 1 is 3. 4:3 means can I write 4 by 3? 3:2 is 3 by 2. Is 4 by 3 less than 3 by 2 or not? 4 by 3 if I simplify I'll get 1.33. And 3 by 2 if I simplify I'll get 1.5. It is less. Yes. And if a is less than b, a plus x is to b plus x is greater than a is to b. Again, x should be positive. If I take the same example, in a ratio 2:3, where 2 is less than 3, a plus x, that is 2 plus, let us say 1, is to, let's say 3 plus 1. If you take this, this is greater than 2:3. That is 3:4 is greater than 2:3. If you want, you can check 3 by 4. Is it greater than 2 by 3 or not? 3 by 4 is 0.75. 2 by 3 is 0.66. It is greater. Right? It's a very useful statement when it comes to some of the complex questions there. Now, these are a few important points on ratios. We'll apply them and solve a few questions here. The first one. If a is to b equals to 2:3, the value of 2a square plus 3b by 3a square minus b is. Now, as we discussed, when I say a is to b is 2:3, it's not necessary that a is 2 and b is 3. I told you in that example, when I say boys and girls are at the ratio 3:2, it's not necessary that boys are only 3 and girls are only 2. Similarly, when I say a is to b is 2:3, a is a multiple of 2, b is a multiple of 3. If I substitute this here, 2a square plus 3b by 3a square minus b, 2 into 2k whole square plus 3 into 3k by 3 into 2k whole square minus 3k. If you look at this, 4k square into 2, 8k square plus 9k by 4k square into 3, 12k square minus 3k. If I take k common, 8k plus 9. If I take k common, 12k minus 3. So the answer is 8k plus 9 by 12k minus 3. But we don't know what is k value. K can be anything. If it is 1, that means if the numbers are 2 and 3, I'll get 17 by 9. If k is 2, you get a different answer. For every different value of k, the result will be different, means we cannot answer the question. The answer is cannot be determined. But I'm afraid normally what mistake we do here is, in the place of a, we substitute 2. In the place of b, we substitute 3 and try to solve the question. And you will get 17 by 9 and you will go for it, especially when there is an option. But please remember, it's not necessarily 17 by 9. It can take any value depending on what is k value, right? So this question is cannot be determined. Let's take up the next one. If a is to b equals to 2:3, b is to c equals to 4:5, c is to d equals 2:7, find a is to b is to c is to d. Now, how do we connect the ratios? The basic rule here is, which you have to identify the common term in two ratios, common term, and then rise it to a common value. Rise this value to a common value. Let me explain what I mean by that. Suppose if I take a is to b is 2:3, b is to c is 4:5. What is the common term in these two ratios? B. What is b value corresponding term here? 3. It is 4. I should rise it. Most of the time rising. Very few cases you can reduce it also to a common number. So you have to rise these two numbers to a common number. What is the common number or common multiple for 3 and 4? 3 4s 12. We'll try to make b value 12 here as well as here. How can I make 12? By multiplying with 4. But please remember, if you are multiplying a term with 4, you have to multiply both terms with the same number. Then only you maintain the same ratio. So if I multiply both these terms with 4, I'll get 8:12. Here I want to make it 12, means I should multiply this with 3. Again, you should multiply both the terms. It will be 12:15. 12:15 can be simplified back to 4:5, right? Okay, now We can write A is to B is to C means when there is a common term B as 12, when B is 12, A is 8, when B is 12, C is 15. Now, if I take C is to D, it is 2 is to 7. Now, the common term for both of them is C. C is 15 here, C is 2 here. Again, raise them to a common multiple. 15 2 is 30. So, we raise this to a common number of 30. Multiply, how do you multiply? How do you get 30? By multiplying with 2, but you have to multiply all the terms with 2. And here you have to make it 30 means you have to multiply with 15 both the terms. So it will be 16 is to 24 is to 30. Here if I multiply with 15, it will be 30 is to 105. So now if I write A is to B is to C is to D. Now when C is 30, A and B are 16 and 24. And when C is 30, D is 105. Right? So this is how we combine the ratios. Now, there is a shortcut for this, but the shortcut has its own limitations. What is the shortcut? What is the limitation? We'll discuss this. When I have A is to B is equal to 2 is to 3, B is to C is equal to 4 is to 5, C is to D is equal to 2 is to 7. When I want A is to B is to C is to D, the shortcut limitation is we can apply the shortcut only if I have a situation like this. It ends with B, starts with B, ends with C, starts with C. If it is like this, you can write the shortcut. And the shortcut is this. For A, this is the ratio. This is the term. And is there any ratio above it? No. Take this 2 multiply with the following first terms. Multiply with the following first terms of the ratios. If you multiply with the following first terms, 2 into 4, 8, 8 into 2, 16. Now, similarly take B, 3 and multiply with the following first terms. Following ratios, first terms means 3 into 4, 12, 12 into 2, 24. And now let's say C starts with 5. I'll multiply the following first term, but there is a ratio before this. In the case of A is to B, what happened? There was no ratio above it. But here, when I take 5, there is a ratio before. There is a ratio before. So, for following ratios, first terms you are multiplying, there is a ratio before previous ratios, second terms you multiply. If there is a ratio previously there, you multiply the second term. So, 5 into 3, 15 and following ratio first term 2. Previous ratio second term, following ratios first term. So 5 3 is 15 into 2, 30. And take a corresponding value for D7. There is no ratio to follow, only previous ratios. Previous ratios, what terms you have to multiply? Second terms, 7 into 5, 35, 35 into 3, 105. So following ratios first terms, previous ratios second terms. 2 into 4 into 2, 16. 3 into 4 into 2, 24. These two are easy because there is no ratio before. But here for C, there is a ratio before means multiply the second term. There is a ratio after that, multiply the first term. D is also easy because there is no ratio to follow. For all previous ratios, multiply second term. 7 into 5, 35 into 3, 105. This is the shortcut, right? Let's take up one more example. 5 years ago, if the ratio of ages of two persons is 7 is to 5, which of the following can be the possibility is asking, can be the ratio of their ages now? Now, 5 years back, if the ratio is 7 is to 5, let their ages be 7k and 5k. So today means you will be adding same number 7k plus 5 and 5k plus 5. Right? So now what this ratio can be? Now if you observe, you are adding same number to both the terms here. Why? Because age 5 years back to today, each person will increase by 5 years. Now, in a ratio 7 is to 5 where 7 is greater than 5, you are adding same number to both the terms means what happens to the ratio? We have discussed a couple of points on lesser inequality and greater inequality. The point we discussed is if A is greater than B, A plus X is to B plus X is less than A is to B. Now in this ratio 7 is to 5, 7 is greater than 5 means if I am adding same number, 7k and 5k are there. If I am adding same number to both of them, the ratio is going to be less than 7:5 or not? Right? What is 7:5 or 7 by 5? 7:5 or 7 by 5 is 1.4. Which of them is less than 1.4? I had to check. 5 by 3. What is 5:3 or 5 by 3? 5 by 3 is 1.66. No, I can't take this. 8 by 5, 1.6. I can't take this. The ratio has to be less than 1.4. 3 by 2, 1.5. I can't take this. It is more than 1.4. So this is ruled out. This is ruled out. Then this is the only one left. Let us take 4 by 3. If I take 4 by 3 is 1.33. The ratio has come down or not? Yes. Because 7 is greater than 5, when you are adding same number to both the terms, the ratio will be less than 7:5. Hence, only possible answer is 4:3. Right? So these are few important points on concepts of ratio. We will discuss the concepts of proportion. What is a proportion? If two ratios are equal, we say they are in proportion. Say if A is to B equals to C is to D, we say that A, B, C, D are in proportion. And if A is to B equals to C is to D, we say product of extremes A into D equals to product of means. How it comes? Basically, A is to B is nothing but A by B, C is to D is nothing but C by D. It's like cross multiplication. AD equals to BC. So if A is to B is equal to C is to D, product of extremes equals to product of means. A into D equals to B into C. Right. If A is to B or A by B, is C is to D or C by D, then there are three important rules. First one is A plus B by B equals to C plus D by D. This is called Componento Method. How this comes? If you add both sides, since they are equal, if you add 1 to both sides, because they are equal, you can add the same number or subtract the same number. So now I am adding 1 both sides. When you simplify, you will get A plus B by B. This will be C plus D by D. Suppose if you subtract 1, you will get A minus B by B equals to C minus D by D. That is called dividendo method. So A by B equals to C by D. By subtracting 1 both sides, we will get this. And now that we know componendo method and dividendo method, the combination of these two is componendo dividendo method. If I write first one by second one, B gets cancelled, here D gets cancelled. We'll have A plus B by A minus B equals to C plus D by C minus D. This is called componendo dividendo method. Very useful approach in simplifying especially some of those algebraic equations. Right? Okay. Now then, what is continued proportion? If A is to B equals to B is to C, A, B, C are said to be in continued proportion. And for example, 3 is to 6 equals to 6 is to 12, because this is 1 is to 2, this is also 1 is to 2. So then we say that 3, 6, 12 are in continued proportion. Some of you may think, sir, is it not in geometric progression? Of course it is, because it is into 2 into 2, it is geometric progression. So this is synonymous with geometric progression. But anyhow, progressions we will take a different session. So in this session, we will continue with this proportion concept. If A is to B equals to B is to C, A, B, C are said to be in continued proportion. Now here, if I apply the product of extremes is equal to product of means, B square is equal to AC, or B is equal to square root of AC. And this B is called the mean proportional of A and C. Here the B is called mean proportional of A and C. And C is called the third proportional of A and B. If A is to B equals to B is to C, B is called the mean proportional of A and C, and C is called third proportional of A and B. Please remember, this third proportional term comes in continued proportion only. In the previous case, when I say if A is to B is equal to C is to D, here we don't call C as the third proportional of A and B. The third proportional term is used when A is to B equals to B is to C, then we say C is the third proportional of A and B. You may call D as fourth proportional of ABC, when if A is to B is equal to C is to D. But we don't call C as third proportional. Third proportional term is used in continued proportion. And as I said, continued proportion is synonymous with geometric progression, because if three numbers are in continued proportion, are they not in geometric progression? They are, right? Okay. Next, if I take 2 by 3, is it not equal to 4 by 6? It is also equal to, say, 6 by 9. They're all equal. 2 by 3, 4 by 6, 6 by 9. You cancel 2, you get 2 by 3. You cancel 3 with 3, you get 2 by 3. Suppose if I add all these numerators, 2 plus 4 plus 6 by 3 plus 6 plus 9, how much it is? 12 by 18. 12 by 18 is nothing but 2 by 3. That is nothing but equal to the original fraction. So that's why we say if A by B equals to C by D equals to E by F and so on, A plus C plus E, sum of the numerators and so on by sum of the denominators will be equal to original fraction itself, A by B. And this applies for even subtraction also. Suppose if I write 2 minus 4 minus 6 by 3 minus 6 minus 9, how much it will be? It will be minus 10 minus 8. It is minus 12. Minus minus gets cancelled. 8 by 12 is 2 by 3 or not? Yes. So this applies not only for addition, even for subtraction. Very useful rule again in simplifications of equations. Now, these are few important points on proportion. Now, we'll apply them and solve a few questions there. The first one, the ratio of the ages of two friends is 4:5 now. 2 years ago, the ratio of their ages was 7:9. Find their present ages. The ratio of ages of two friends is 4:5 now. Present ages of the two guys is 4x and 5x, because they're in the ratio 4:5. If there are 4x and 5x now, 2 years back, 2 years ago, each one was 2 years younger, so 4x minus 2, 5x minus 2. But 2 years ago, the ratio of their ages was 7:9, means equate this to 7:9. You can say product of extremes is equal to product of means. 9 into 4x minus 2 equals to 7 into 5x minus 2. You can say 36x minus 18 equals to 35x minus 14. If x comes this side, x equals to 4. Once x equals to 4, now we are interested in their present ages. The present ages are 4x and 5x. 4 into 4 and 5 into 4, that is 16 and 20. This is our answer. Right? Let's take up one more. Incomes of Soras and Chand are in the ratio 5:4. Their expenses are in the ratio 3:2. If each one saves 6,000, find their incomes. Now here, incomes are in the ratio 5:4 means we can write incomes as 5x and 4x. The expenses, these are income of Soras and Chand. The expenses are in the ratio 3:2 means we can write expenses as 3y and 2y. Income minus expenditure will give savings. The savings is 6,000. 5x minus 3y is 6,000. Savings of Chand also is 6,000. 4x minus 2y equals to 6,000. When we solve these two equations, we get the answer. This is using simple equation concept. Or now, the second approach will be, we'll use the ratios concept only. Incomes of them are 5x and 4x. Now, there's each one saves 6,000. Now, the income minus savings will give expenditure. 5x minus 6,000 here, it is 4x minus 6,000. Now, the ratio equals to 3:2 means we can write product of extremes, product of means and get the answer. Here we are getting two variables and two equations. We are trying to get only one variable and one equation. If you multiply this with 2 into 5x, 10x minus 12,000 equals to 3 into 4x, 12x minus 18,000. 10x comes this side, 2x equals to 18,000 comes this side, 6,000. Or x equals to 3,000. Once x equals to 3,000, their incomes are 5x and 4x means 3,000 is 15,000 because x is 3,000 and 3,000s will be 12,000. Right? Okay, this is second approach. And there is a shortcut here. If you observe, the incomes are in the ratio 5:4. The expenses are in the ratio 3:2. This is a special case. It's not possible all the time. It's possible here because what is the difference in the number of shares? 2 shares. Here also 2 shares. Both cases I have a difference of 2 shares, and both cases I have a difference of 6,000 between income and expenditure. Savings is nothing but difference between income and expenditure. Both cases I have a difference of 2 shares. Both cases I have 6,000 means I can say 2 shares worth is 6,000. 1 share worth is 3,000. So 5 shares worth will be 15,000. 4 shares worth is 12,000, I can say. Simple approach. So this is the shortcut. Done? Okay. Next, one more question. Mean proportion of two numbers is 12 and their third proportion is 96. Find the two numbers. Now, if the two numbers are A and B, mean proportion of two numbers is 12 means what? If A is to B equals to B is to C, we call B as the mean proportion of A and C, I said. Now here, if I take two numbers as A and B, the mean proportion is 12 means A is to 12 is equal to 12 is to B. Then we say 12 is the mean proportion of A and B. Now, if I write product of extremes is equal to product of means AB equals to 144. This is first equation. Now, their third proportional means third proportional of A and B is 96 means A is to B is equal to B is to 96. Then we say 96 is the third proportional of A and B. As I said, if A is to B is equal to B is to C, C is the third proportional of A and B we discussed. Now, again if I write product of extremes equals to product of means B square. But now, in the place of A, I can write it as 144 by B here. If I substitute in the place of this A, the first equation, A equals to 144 by B. 144 by B into 96 equals to B square. B square goes other side, B cube equals to, this is 12 square into, this is 12 into 8. This is nothing but 12 cube into 8 is 2 cube. B cube equals to 12 cube into 2 cube means B is equal to 12 into 2, 24. Once B is 24, we said A is equal to 144 by B. A value is 144 by 24, 6. So hence, now the two numbers are 6 and 24. This is the answer. So these are few questions on proportion concepts. In this session, we will be discussing variation concepts. Then we will apply these concepts and solve a few questions. Students, variation concepts is very important because the whole of time and work concepts depend on these variation concepts. Even a part of speed, time and distance questions, if you are good at variation concepts, you can answer easily there. Right? So what is variation? We will discuss with an example. Suppose if there are 20 men, they will complete the work in 60 days. If there are 10 men, how many days they take? Is it 30 days or 120 days? When people are less, they will take more time. When people become half, you require double the time, you require 120 days. If there are 40 people, 20 people can complete a job in 60 days. 40 people means people doubled, so the time will take only half, that is 30 days. What if there are 50 people? How many days they take? We'll discuss, we'll come back to that. Let me take one more example. Suppose if I buy 20 pencils, it will cost me 60 rupees. Now, if I have to buy 10 pencils, it will cost me how many rupees? For 20 pencils, if the amount is 60, for 10 pencils, less number of pencils you buy, it costs you less, so it will be 30 rupees. Or if I buy 40 pencils, yes, 20 pencils 60, 40 pencils will cost you 120. And if there are 50 pencils, yes, we can calculate. We'll come back to that. If you observe these two examples, here in this example, when number of pencils is coming down, their total cost is also coming down. When the number of pencils increasing, the total cost is also increasing. In other words, a decrease in one item makes a corresponding decrease in the other item. Or an increase in one variable makes a corresponding increase in the other variable. Here, these two are in direct variation. They are in direct variation, or we say they vary directly. Whereas here, if one decreases other increases. When one increases, the other decreases. Because they are changing inversely, we say they are in inverse variation. A decrease in one item makes a corresponding increase in the other item. An increase in one item makes a corresponding decrease in the other item. Fine. So now, if you observe these two numbers, 20 and 60, 20 into 60 is 1200, or 10 into 120 is 1200, or 40 into 30 is also 1200. So here the product has been constant. What about here? Is the product constant? No. 20 into 60, 1200, 10 into 30, 300. The product is not constant. Then what is constant? If you observe keenly, 20 by 60 is 1 by 3, 10 by 30 is 1 by 3, 40 by 120 it is 1 by 3. So the ratio is constant. So what we can say is, if two variables are in direct variation, the ratio of the two variables is constant, whereas here the product is constant. Product is constant in inverse variation. So when I ask you 20 pencils cost 60 rupees, 50 pencils cost how much, means we can say 20 by 60 equals to 50 by x. If I simplify, 23 is x equals to 150. Here 20 men will complete a work in 60 days, 50 men will complete in how many days, means number of men and days are in inverse relation. So the product has to be constant. So we say 20 into 60 equals to 50 into, let us say, x. We have to find out this. I am assuming x. You can see 0, 0, 5 ones, 5 fours. We can see it is 24 days. So same numbers, you can see one case we are getting 150 answer, another case we are 24 days, because the context is completely different. This one is, the first one is a context or a question of direct variation, whereas the second one is a question of inverse variation, right? So whatever we have discussed with the example, if I have to summarize it, what we can say is, if A varies directly with B, A by B is constant. That means first time A by B value, as you can see, first time A by B value, second time A by B value is same. So A1 by B1 equals to A2 by B2. Or if A varies inversely with B, 1 by B I am writing just to say inversely, the product is constant. That means first time the product and second time the product is same. If A varies directly with B, A by B is constant. We can say A1 by B1 equals to A2 by B2. If A varies inversely with B, then A into B is constant, or we can say A1 B1 equals to A2 B2. Here I can also write this as, if A2 goes this side, A1 by A2 will be equal to B1 comes right hand side, B1 by B2. Whereas here if you see the same thing, if I write it, A2 goes other side, A1 by A2 equals to B1 comes this side, B2 by B1. A1 by A2 equals to B2 by B1, because it is an example of inverse variation. They vary inversely here. Here they vary directly. Right? So now, if there are more than two variables, how do we answer it? Let us see. If there are three variables A, B, C, if A varies directly with B, A varies inversely with C. If A varies directly with B, we discussed A by B has to be constant. If A varies inversely with C, A into C has to be constant, means finally A into C by B is constant. Like this we can extend the rule for any number of variables. AC by B is constant, means first time A1 C1 by B1 equals to A2 C2 by B2. Let me take a case of typical time and work questions. In a typical time and work question, we'll have number of men, number of days they are working, hours per day they work, and work they do. These are the four variables more often we get in a typical time and work question. Now if I take men as constant and compare with each another variable, how men and days are related? More men they take less days, less men they take more days. It is inverse relation. M varies, inversely with D. 1 by D I am writing means it's inverse relation. Hence what is constant? Product is constant, M into D. Men and hours per day. More men, you have to work less hours a day. Less people, you have to work more hours per day. So again it is inverse relation. Men and hours also is inverse relation. See, basically days or hours is a unit of time. So time, people and time are inverse related. More people you take less time, less people you take more time. So inverse relation means again M into H or M by H. Inverse means product, M into H. Men and work, if you do more people, the total output will be more. So they will do more work. Less people, they will do less work. It is direct relation. Men and work are direct related means direct relation means ratio is constant. So by W is constant. In other words, we write it as M1 D1 H1 by W1 equals to M2 D2 H2 by W2. You can see here. And you refer to any source of material that is available for time and work, you will find it as if it is a formula. This is not basically a formula, it is extension of variation concept, where direct variation we are saying ratio constant, inverse variation product constant, right? Now these are the basic concepts of variation. We'll use these concepts and solve few questions there. First one, A varies as the square of B. When A is 12, B is 16. What is A when B is 9? A varies as the square of B. When I say as the square of B, unless I use the word inverse, it is assumed it's direct variation only. A varies as the square of B means A by B square is constant because it is direct variation. Or in other words, A1 by B1 square equals to A2 by B2 square. What is A first time? 12. What is B1? B is 6 means B1 square. So 6 into 6 equals to second time I have to find A. What is B? 9. 9 square. 9 into 9. You can see 6 2s, 2 3s, 3 1s, 3 3s. If I simplify, I get A equals to 27. Right? A simple question. Let's take up one more. A varies inversely with the cube of B. When A is 12, B is 4. Find the value of A when B is 6. A varies inversely means 1 by with cube of B, B cube. Inverse variation means product is constant means A into B cube has to be constant. That means first time AB cube value, second time AB cube value should be same. Now here when A is 12, B is 4 means you can write 4 cube. Second time I have to find A when B is 6 means 6 cube. If you simplify 12 into 64 equals to A into 216. 12 ones, 12 18s. We can say that it is 2 9s to 32s. So we can say A equals to 32 by 9. Right? So like this we can directly use concept of variation. Let's take up one more. 20 men working 8 hours a day for 30 days dig a canal of 14,400 meters. 25 men working 10 hours a day for 24 days will dig a canal of how many meters? So we just discussed M1 D1 H1 by W1 equals to M2 D2 H2 by W2. We don't have to, again, I have just explained you how this has come. So we'll straight away take it as formula and answer it. First case, 20 men. They're working for 30 days, working 8 hours a day. How much work they do? They do 14,400 meters of canal. Second case, 25 men. How many days? 24 days. Working how many hours a day? 10 hours a day. Will dig a canal of how many meters means how much work they can do. We have to find this. Matter of calculation, you can see here 1 0, 1 0 gets cancelled. 3 8s, 24, 24 gets cancelled. I can say 5 4s, 5 5s, 4 3600. If I cross multiply, W2 is equal to 5 into 3600 is 18,000. So 18,000 meters is what they can do. Right? Okay, let's take up one more. The value of a precious stone varies as the square of its weight. It is broken into 3 pieces whose weights are in the ratio 2:3:5. if its original value is 10,000, find the loss due to breakage, a standard examination question. Now here, value of a precious stone varies with the square of its weight. So W square, or I can say V by W square is constant, or I can say V is equal to K into W square. Now, the original stone was broken into 3 pieces whose weights are in the ratio 2:3:5 means let the weights of these 3 pieces be 2x, 3x and 5x. After it is broken, the 3 pieces weights are 2x and 3x and 5x. The weight of the stone before it was broken is, all these 3 pieces is one stone only, right? So 2x plus 3x plus 5x, it is 10x. So the value before it is broken, the value is K into W square. W is 10x. 10x whole square, it will be 100x square into K. It is 100kx square. This is the value before it is broken. The value of the pieces after it is broken is, we have to take the first piece value. Its weight is 2x means value will be K into W square. K into 2x whole square, 4kx square. Now value of the second piece will be V2 equals to K into 3x whole square. It will be 9x square into K, 9kx square. Value of the third piece will be K into 5x square, because it's K into W square is the value. It is 25kx square means the total value of these 3 pieces after it is broken will be V1 plus V2 plus V3 is 4 plus 9 plus 25, that is 38kx square means original before it was broken 100kx square, now it is 38kx square means the loss equals to 100kx square minus 38kx square. So 62kx square is the loss, but we need to know kx square value. We know that the original value is 10,000, but what is the original value means before it was broken. Before it was broken, the value was 100kx square. If 100kx square equals to 10,000, you can see 2 zeros, you can cancel both sides. Kx square is 100. Now the loss equals to, we said 62kx square. It is 62 into 100. 6,200 is the loss due to the breakage, right? So these are few questions on variation concepts, and students, for more on ratio, proportion, variation and the extension of these concepts are, as I said, are used in time and work. Please reach my profile on Udemy. The link is given below, where you find a course on time and work or work rate, where you find all the concepts of ratio, proportion, variation and also all the concepts of time and work. Thank you.